Hello guys, today let's learn how to determine the R and S configurations of the chiral centers of a Fischer projection. So in the previous lesson, we learned to determine R and S configuration of a tetrahedral chiral center. When it comes to a Fischer projection, these structures contain multiple chiral centers. Let's learn how to find R and S configuration of a given Fischer projection. First of all, the most important thing that you have to keep in mind regarding a Fischer projection is all your horizontal lines are wedges, all your vertical lines are dashes. What does that mean? So, considering the given example, I can rewrite my structure like this. So, this means my chlorine and methyl groups are in back, so that's why they are written as dashes. My hydrogen and OH groups are written as wedges because they are in front. So, we have to keep in mind that horizontal lines are wedges, vertical lines are dashes. When you assign or finalize R and S, this is very important. Let's consider the given example. So according to this, we have three chiral centers. We know now that we can rewrite this structure as this. So we have vertical lines. We can consider that vertical lines as they are in back. So horizontal lines like they are in front. So considering the chiral centers one by one, let's consider the first chiral center. So here this carbon is attached to oxygen, carbon, carbon and hydrogen. So definitely number 1 gets, we have to put number 1 here to oxygen. Then this carbon is attached to 2 carbon atoms. So we have similar competition. Because of the similar competition, we have to consider the next atom attached to that particular carbon. This carbon is attached to oxygen. This carbon is also attached to oxygen. Again, same competition. Then we have to consider the next atom. So this carbon is attached to hydrogen. What about the below bulk group? This carbon is attached to another carbon. So definitely this below group gets number 2. CHO gets number 3. Hydrogen is number 4. Let's check the pattern starting from 1. 1, 2. So it is anti-clockwise. So it can be S. But the thing is, before we conclude or before we finalize our answer, we have to consider the position of our hydrogen. The thing is, our hydrogen is in front. So we have to revise our answer. So this should be R instead of S. So I write it here. So my first chiral center is R. Let's go to the next chiral center. So here this carbon is attached to oxygen, carbon, carbon and hydrogen. So definitely oxygen gets number 1. What about 2 carbons? Then we have to consider next atom. So this carbon is attached to oxygen here. This carbon is attached to oxygen here. That means we have same competition again. Then let's go to the next attached atom. So this carbon is attached to this carbon again. Below carbon is attached to carbon again. Similar competition. Then that carbon is attached to oxygen here. This carbon is attached to oxygen again. Still we have the similar competition. Then here, considering the above bulk group, we have hydrogen, but we have 3 hydrogens additionally. So definitely the below group, this below group gets number 2. this is my number 3 now, the above group, and hydrogen is number 4. Let's check the pattern starting from 1. 1, 2. So this is clockwise. Is it R now? No, it is not R because hydrogen is in front. So we have to revise our answer. So it is S. Second carbon is S. Let's consider the third chiral center here. So we have oxygen atom, we have carbon, carbon and hydrogen. So definitely oxygen gets number 1 priority. Carbon, carbon, similar competition. Then we have to consider the next atom, oxygen here, again similar competition. But above carbon is attached to another carbon. Here it is hydrogen. So definitely the above part gets number 2, below part gets number 3. My hydrogen gets number 4. 1, 2, so it is clockwise, but we have to switch our answer because my hydrogen is in front. So this is S again, right? Now this example is for you guys to test your knowledge. Pause the video and try this out. Are you done? Here's the answer. So guys, I hope you all enjoyed my video today and learned everything very clearly. Thank you very much for watching.